Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we will solve a problem where we use the chi-square distribution and one of the theorems we recently discussed. Let's begin. So, that's the problem I would like to solve with you in this video. So in this case, we are interested in the following random variable, weight. Okay, so x represents the weight in grams of a nail. Okay, now we're going to be assuming that the distribution of that random variable weight is normal. Okay, so x is normally distributed with mean 8.78 and variance 0.16. Next, we draw a sample of 9 observations coming from that random variable x, okay, and we compute s squared, the sample variance. And the ultimate goal of the problem is finding constants a and b such that the probability that the sample variance s squared is between a and b is equal to 90%. Okay, so that's the ultimate goal, finding a and b such that the probability that the sample variance s squared is between a and b is 90%. Okay? Well, let's try and provide a solution to that problem. Solution. So, what's the key to solving that problem? So first, note that we have a random sample of size 9 coming from a normal distribution with some mean mu and some variance sigma squared. Okay, and we are interested, we would like to say something about the sample variance, right? So if you remember, there's this theorem 7.3 that goes something like this. So recall that we have a result theorem that states something like this. If you have x1 x1 x2 xn, right, from a normal distribution with mean mu and variance sigma squared, then let me write it like this: n minus 1 times s squared, where s squared is the sample variance, divided by sigma squared, has a chi-square distribution, remember, with n minus 1 degrees of freedom, right? So that's the key, right? This guy has to do with a random sample of normal random variables, right? And s squared is involved. Okay, so note that what we want here is the probability that s squared lives between a and b, between that interval, is in that interval. But we don't know the distribution of s squared, right? However, we know the distribution of this guy, so we're going to be using that to solve the problem. Okay, so now let me write down what we want. We want A and B such that then we have the probability that s squared is greater or equal to A and less than or equal to B. We want that probability to be 90%, okay, or 0.9. Okay, so that event that we have here is equivalent to this. Let's multiply by n minus 1 and divide by sigma squared, right? Let's do that. So n minus 1 divided by sigma squared. Just that guy. Okay. Note that that quantity is positive, so those inequalities won't be affected by that, right? Okay, so that event is equivalent to this event we had here. Make sense? But now what we have here is that this guy has a chi-square distribution with n minus 1 degrees of freedom, and we have to find two numbers, n minus 1 divided by sigma squared times A, n minus 1 divided by sigma squared times B, that satisfy that condition. We want those guys to be such that the probability that a chi-square with n minus 1 degrees of freedom lives between them is 90%. Make sense? Okay, let me make this look a bit nicer. Okay, so let me just rewrite that and say that what we have here in the middle is just a chi-square with n minus 1 degrees of freedom. Okay, so in this case, remember that we have a sample of size 9, 8. Let's take a look. 9, right? Okay. So n equals 9, right? And sigma squared, I think it's 0.16, but we can check just to be sure. Yeah, 0.16. Okay. Okay. So let's find this guy first, right? Let's find B first. So that quantity we have there, in our case, is the same as 8 divided by 0.16 times B, right? Okay, now from our table, we're going to be able to find a number, right, a percentile of a chi-square distribution with 8 degrees of freedom, such that, and note that we want between these guys to have a proportion of observations equal to 90%, right, or 0.9, right? Okay, so now let's use our table. Okay, so if you go to page 850, right, from your textbook, you'll see that table. Now I want you to take a close look at that figure, right, and note that this table is going to give you areas to the right. Okay, now as I said, what we want is two numbers such that between them we have 90% of the observations for a chi-square with 8 degrees of freedom. So one way of doing that is if to the right of one of those numbers, let me call this guy the upper limit, such that to the right of the upper limit we have 5%, and let me call this guy the lower limit, and if to the left of the lower limit we have 5%, then between them we should have 90%. Make sense? Okay, so since this guy gives you areas to the right, we want alpha to be 0.05, right? We want a number from a chi-square distribution with 8 degrees of freedom to have an area of 5% to the right. That is going to give us our first guy. It's going to help us find B. Okay? Okay. So let's go to the next page, because we are looking for 5% or 0.05, right? That would be the alpha that we want. So 5%, right? This guy is such that the area to its right is 5%, but we need 8 degrees of freedom. So in our case, our guy is this guy. Make sense? Okay, so let me just say that from our table what we have is 15.5073, right? From our table. Okay. Okay. So solving for B, what we have is that B will be this guy, 15.5073 times 0.16 divided by 8, right? Okay, so let me just launch R to do the math here. Let me copy paste that. Just a quick calculation here. We want 15.5073 times 0.16 divided by 8, right? So that's our guy. That would be B. Okay. Now let's find A. Let me be lazy here. I will copy paste this. Let's find A. Let's find A. So we have something similar, right? N minus 1 divided by sigma squared times A. But now, since we want 5% to the left of this guy, and our table gives you areas to the right, okay? So what we need is 95, oh sorry, it's page 850. So what we want, right, is a chi-square, well, a number from a chi-square with 8 degrees of freedom, and we want that number to have 95% to its right. And again, remember, that's because your table gives you areas to the right. So if we have that lower limit having a 95% probability to its right, and then the upper limit having 5% to the probability to its right, then between them we will have the 90% that we want in the first place. So note that our guy is this one, right? Make sense? Okay, so let's write it down. 2.73264. So 2.73264, right? Let me just double check. 2.73264. Excellent. So again, same idea. Now we solve for A. Solving for A, what we have is something similar to what we had here, right? But now, instead of having 15.50, we will have 2.73. But the sample size n remains the same. The variance that we're assuming for that distribution, sigma squared, remains the same, 0.16. So now let's just do the math. Let's use R here. 2.73264 times 0.16 divided by 8, and that happens to be roughly 0.05. Okay, so finally A equals this guy, 0.05 roughly, and B happens to be 0.31, right? Roughly. Okay? Now, this is doing things by hand using a table, right? And it is important to learn how to do this using a table, because remember that our final exam will be, you know, your typical in-class type of exam, okay? But now let me show you how to do this using R, because it's important for you to learn also how to do that, okay? So let's just check that what we have here is true, okay? So the thing is that according to this table, what we have is that the area to the right of 2.73264 for a chi-square with 8 degrees of freedom, well, that proportion of observations to its right is 95%. Okay? Now, there's a function, special function in R, that gives you the CDF, well, yeah, gives you the inverse of the CDF. Okay? So, for instance, using chi, this function q chi square, right? Q chi sq, right? In this case, which again, this function is the inverse of the CDF, of the cumulative distribution function. So in this case, what we want is, hey R, give me a number coming from a chi-square distribution with 8 degrees of freedom such that the area to its left is 5%. So the thing is that, again, R, this function here, has to do with areas to the left, okay, like a regular CDF, okay? So, and this is the inverse of the CDF, so that's the information that R is expecting you to give, right? The area to the left that you want. So if you want 5% to its left with 8 degrees of freedom, this guy. So again, if this guy has 5% to its left, that means that it has 95% to its right. So, see? Now the other one, right? For that one, what we wanted was 5% to its right, okay? So if you want 5% to its right, then you have 95% to its left, okay? So that was on the next page, right? So let's check that this is correct. See? So the thing that you have to remember, that I would like you to remember, is that if you are using that table from our textbook, take a look at that graph and remind yourself, oh, this table is giving me areas to the right. But if you're using R, remember that what this guy, Q chi-sq, right? Q chi-square, as in quantiles of a chi-square, that function is going to need you to give areas to the left. Okay? Makes sense? And then it's going to give you the quantile, the number, such that the area to its left is this. Make sense? Okay. So, in summary, what we did here was we used theorem 7.3, which has to do with sample variances, right? And that's why we chose to use that theorem, because it had to do with sample variances under the conditions that we had, because in this case we have a random sample of normal random variables. Make sense? Okay, so that's it. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.